This topic is about the formula for changing the base of logarithms and using the formula in a variety of contexts to solve problems. So let's derive the formula first. Let k be equal to log base a of x. Then we know a to the power of k will be equal to a to the power of log base a of x, which implies a to the power of k must be equal to x. Take log base b on both sides. Then we get log base b of a to the power of k is equal to log base b of x. If we apply the laws of logs, that's k times log base b of a is equal to log base b of x. If I divide through by log base ba, I get k is equal to log base bx over log base b of a. Therefore, because k is both equal to this and that, they must be equal. So log base a of x must be equal to log base b of x over log base b of a. And that is called the change of base formula. As a consequence of this formula, if you let x be equal to b in the formula, and change your base formula, then what we end up with is log base a of b is equal to log base b of b all over log base b of a. Now log base b of b, which is the numerator, is just b to the power of something is equal to b, which is just 1. So 1 on the numerator over log base b of a. And what you end up with is, therefore, you've got a consequential formula, which is log base e of b is equal to 1 over log base b of a. So these are two formulas that you need to change the base of an exponential of a logarithm. Let's go through a few examples to demonstrate these two formula in action. Okay, so in this example, I can see I've got a log base 5x and log base x 5, which means the base and the input have changed places, which means I need to use a second formula. So the second formula is using log base ab is equal to 1 over log base ba. Okay, so we've got, so using this formula, we know that log base x of 5 will be equal to 1 over log base 5x. So log base 5x plus 6 log base x5 is equal to 5. I can rewrite this second term as plus 6 times 1 over log base 5x is equal to 5. Now we've got a 1 over log base 5x. So what we need to do now is we need to multiply through by log base 5x. So times by log base 5x throughout every single term. So log base 5x times log base 5x will give you log base 5x squared plus 6 times 1 over log base 5x times by log base 5x, just get us rid of that fraction. So we're left with the 6 is equal to 5 times log base 5x, which is that. Now we can see that's a hidden quadratic. So first thing I'll do is rearrange to make the right hand side equal to 0. So I get log base 5x squared minus 5 log base 5x plus 6 is equal to 0. So if I let y be equal to log base 5x, then I've got y squared minus 5y plus 6 is equal to 0. I factorize this, and I've got minus 3 in one and minus 2 in the other one. So we get positive 6 and then minus 5y as middle term, which means y is equal to 3 or y is equal to 2, which means log base 5 of x is equal to 3, or we've got the case where log base 5 of x is equal to 2. So if we take 5 to the power of both sides, we get what x is equal to. So x will be 5 to the power of 3, or x will be equal to 5 to the power of 2, which implies x will be equal to 5 times 5 times 5, which is 125, and x will be equal to 25. Now these work because x has to be greater than 0. They both satisfy x greater than 0, so that must work. So there must be solutions to the equation. So next example, solve giving your answer to 3 significant figures. Log base 2x is equal to 8 plus 9 log x, log base x2. Again, they're flipped over. So using, again, the second change of base formula, which is log base ab is equal to 1 over log base ba. Then I get log base x2 is equal to 1 over log base 2x. So they're flipped over. So that means log base 2x stays the same, h stays the same. 9 times log base x2 becomes 1 over log base 2x. Okay, so that means I've got log base 2x is equal to 8 plus 9 over log base 2x. So I need to times through by log base 2x to get rid of that fractional part. So I end up getting log base 2x all squared is equal to 8 times log base 2x plus 9. If I take everything to the left-hand side, I end up getting log base 2x squared minus 8 log base 2x minus 9 equals 0. Again, it's the Hadron quadratic. So let y be equal to log base 2x. And then I've got y squared minus 8y minus 9 equals 0. If I factorize it, I've got y minus 9 and y plus 1, which means y is equal to 9 or y is equal to negative 1, which means log base 2x must be equal to 9 or log base 2x is equal to minus 1. If I apply 2 to the power of, I get rid of log base 2, so x must be equal to 2 to the power of 9 or x must be equal to 2 to the power of minus 1. If I put 2 to the power of 9 into my calculator, I get 512. And if I put 2 to the minus 1 into my calculator, I'll get obviously half. So those are my solution. These will both work as the correct as x is greater than 0 in both cases. So solve giving you answer to 3 significant figures. Log base 4x plus 2 log base x4 is plus 3 is equal to 0. So it's again using the same formula, which is the second formula. I know that log base x4 is equal to 1 over log base 4x. So if I write it out using this formula, I get 2 over log base x4. I'm sorry. So log base x4 is 1 over log base 4x. So like that, plus 3 is equal to 0. I need to multiply through by log base 4x. So I get log base 4x squared plus 2 plus 3 log base 4x is equal to 0. Again, if I let y be equal to log base 4x, Then I've got y squared. The last term is 3 lots of y. The middle term is plus 2. Gives me that. If I factorize this, it's factorized really easily. 2y plus 2 times y plus 1, which means y is equal to negative 2, or y is equal to negative 1, which means log base 4x is equal to minus 2, or log base 4x is equal to minus 1. X will be equal to 4 to the power of minus 2, or x will be equal to 4 to the power minus 1, which means x is equal to 1 over 16, or x is equal to a quarter. X is equal to 0.0625, or x is equal to 0.25. Again, as x is greater than 0, these two do work out, because we need the input to be greater than 0. Next example, solve giving your answer to 3 significant figures. Log base 2x plus log base 4x is equal to 2. Now here you can see the input and the base have not changed bases, so this must be the first formula. So let's write down, the first formula. So the formula is, so we're going to be using this formula, so let's write it down. Here, log base ax is equal to log base bx over log base ba. Now what I want to do is change this 4 into base 2, basically. We want all the bases to be the same. So we want to change 4 to 2. So in this case, we'll let a be equal to 4 and b is equal to 2, because we want to change the 4 to a 2. So if we substitute into this formula, then we get log base 4x is equal to log base 2x over log base 4. Now, because the denominator, we can simplify. So the numerator stays as log base 2x. So this is log base 4x. It's the same thing as log base 2x over log base 4. 2 to the power of something is 4. 2 to the power of 2 is 4. So the answer must be 2 at the bottom. So we can replace log base 4x with log base 2x over 2. So therefore, log base 2x plus log base 2x over 2 is equal to 2. Now we know if we collect the like terms, log base 2x plus a half log base 2x is 3 over 2 log base 2x, which is equal to 2. Which means 3 log base 2x is equal to 4. By multiplying both sides by 2. If I divide by 3, I get log base 2x is equal to 4 over 3. Now I've got, and to find the, obviously, x, so I need to do 2 to the power of log base 2 to get rid of the log base 2 is equal to 2 to the power of 4 over 3, which means, which means x must be equal to 2 to the power of 4 over 3. Put that into a calculator, we get 2.51984 blah blah blah, which means x is equal to 2.52 to 3 significant figures. Okay, the last example now. So solve log base 2 minus 3x is equal to log base 6x squared minus 19x plus 2. So we want to change the 9 to a 3. That means we're using the first formula. So using log base ax is equal to log base bx over log base ba. We want to change the 9, a be equal to 9 to a 3 and b equal to a 3. Then we get log base 9. Oh, in this case, we also have x is equal to 6x squared minus 19x plus 2, because our input here is not x, it's that. So we need to keep the input the same. So log base a of 6x squared minus 19x plus 2 will be equal to a log base b, so log base 3 of 6x squared minus 19x plus 2. I don't know why the 2 changed to a 9. Plus 2 all over log base 3 of 9. Okay, now we can see clearly the denominator will cancel out. So that is the same thing as log base 3 of 6x squared minus 19x plus 2. 3 to the power of something is 9. 3 to the power of 2 is 9. So that must be 2. So that means log base 3 of 2 minus 3x is equal to log base 9 6x squared minus 19x plus 2, which is the equation we're trying to solve, becomes log base 3 of 2 minus 3x is equal to log base 3 6x squared minus 19x plus 2 over 2 using star. So using this, okay? Okay, so now I'll multiply by 2, so I get both sides by 2, so I get 2 log base 3 2 minus 3x is equal to log base 3 of 6x squared minus 19x plus 2. Using the laws of logs, I know that's the same thing as log base 3 2 minus 3x squared is equal to log base 3 of 6x squared minus 19x plus 2. Okay, because they're both log base 3, I can do 3 to the power of and get rid of both of them. So I get 2 minus 3x squared is equal to 6x squared minus 19x plus 2. When I expand 2 minus 3x squared, I get 9x squared minus 2 lots of 6x, which is minus 12x, plus 4 is equal to 6x squared minus 19x plus 2. If I take everything to the left-hand side, I get 9x squared minus 6x squared, which is 3x squared, minus 12x plus 19x, which is plus 7x, and 4 take away 2, which is plus 2 equals 0. And then if I factorize it, I get 3x and x. I've got plus 2 here and plus 1, which means x is equal to a minus third, or x is equal to minus 2. Now, are they both valid? 2 minus 3x is always positive for negative numbers, so that is valid. And 6x squared minus 19x plus 2 will also be greater than 0 for both these values. So both valid, as 2 minus 3x is going to be greater than 0 for x is equal to negative third and x is equal to minus 2, because if you substitute in, you can get a positive number. And 6x squared minus 19x plus 2, the minus 19x will become positive because it's a negative number. So the whole thing will also be positive. So therefore, x equals minus third and x equals negative 2 are both valid answers.